So hopefully you guys can see this. I was going to talk about data science and Wardley mapping. So apologies have been a bit quiet in recent years. Throughout COVID probably is the reality of it, but I guess I've been quite busy. I sold my first company I founded in about 2007, slightly hubristically, as one of the UK's fastest growing AI tech companies. So I feel like I know something about this space, even if I've got a lot to learn. And I guess the other thing I've been doing is building or helping build a consultancy in sort of the tech legal space, so compliant by design, and I use Wardley mapping in all of these endeavors. What do I like about Wardley mapping? I had a little blog post, which I did the last time I did some sort of talk at MapCamp, and it was about a jet engine. And basically all my colleagues said, who cares why you talk about jet engines? So I think it's useful because one of the interesting things about a Wardley map is it starts to allow you to have the discussion and make sensible suggestions and ideas around systems that you don't totally understand. And I'm assuming that lots of people on the call aren't necessarily data science or machine learning engineers. And so, you can start to understand dependencies and things in systems that you only have some vague recollection of. And the thing I talked about in the blog or the last post was structural deepening. And the structural deepening, the idea is that as a collection of components called an assembly gets more mature or evolves, you start to add in additional components. Essentially, it gets more complicated. And so what I was really going to do is talk about that in the context of data, or thinking about data. So structural deepening of data, which hopefully will be more applicable to some people than a jet engine. And the things we're really interested in, I guess, is the co-evolution of various sorts of competing technologies, which I won't get into in detail because there's not enough time, but happy to talk afterwards. And another thing I got a lot of criticism for was this diagram, because everyone's like, no idea what it's about. So I'm hopefully going to flesh out some machine learning in the next 25 minutes with a sort of Simon Wardley-esque pace of 100 slides. I should say before I start that almost all of the Wardley map, 90% of the Wardley maps I do are basically sketches on a piece of paper in a notebook. They aren't designed to either collaborate with necessarily or be teaching aids or other. But I've started to put things together that look more like sort of, I guess, teaching aids in various. So I'm interested in patterns. The thing I like about the Wardley map is in principle, you can start to spot stuff that's interesting, or spot stuff that's going wrong, or spot stuff that's going right. And what the patterns look like, they look like the change in evolution of a component across some sort of phase transition, or the dependency or componentization of something. And I was going to talk about that in the context of machine learning. So when I got into this, I guess one of the things I was struggling with early on is how to operationalize various bits of this. Thinking about the structural relations of components. And one of the things that has been done elsewhere is this work by NASA on TRL levels. So the idea is, it goes from an idea where you understand the principle of something about why it should work, all the way through to the first working version of it. And so in my head, the TRL levels sort of span this genesis phase. And so you start at TRL1 and you get up to TRL9. Beg your pardon. And you don't necessarily know why you get started, right? You discover something you weren't looking for. I put a little reference down here on the serendipity of invention, but you find something you weren't looking for, or you accidentally solve something. And that sort of, I think, is the beginning of the data journey a little bit. So when I started doing this a couple of years ago, or trying to find some sort of better formula, more structured formulation, I guess I was thinking a lot about TRL levels, and TRL levels sort of again go from this idea of having nothing to something. So what would that look like in data? Patterns in data science. I'm going to split the talk into sort of three parts: patterns in data science, patterns in machine learning. The first thing to say about patterns in data science, or patterns in data, is they're becoming much more prevalent because the amount of data is going up. And so often when I'm teaching, I'm sort of talking about this data value chain on the right-hand side, and I get on left-hand side. And I guess when Simon talks about capital, for the most part, I'm talking about data and to a certain extent knowledge. And we'll see that I use the word, at least in this presentation, slightly different from the way he does. And I came across this paper a while ago called Data Readiness Levels by, I guess, Professor Neil Lawrence. Was at, I think, University of Sheffield perhaps, but ended up going via Amazon to Cambridge. And actually in his characterization of data readiness levels as a corollary to technology readiness levels, he has three bands, and I've sort of extended it to 4, and just to keep it consistent with Simon's framework. But the idea is that somewhere on the left-hand side, we start with these different stages within, or different tiers within a type of capital, in this case data, and we end up with, you know, full high-grade data on the left-hand side. And if I think about this in the context of building a team, you know, often it depends what the company you're coming into, but I guess the context of this is I started a new company about 3 years ago, and have lots and lots of user needs. Wouldn't it be great if we could do X? So we've got a new purpose at the top on the map, and we've got a ton of executives saying, can AI solve all our problems? And the first part of this sort of data journey is figuring out what, if anything, is available. So often you get, you know, we definitely have it somewhere. You know, one of the departments that you work with or work for, or work for you, as the case may be, have it, and then it turns out they don't quite have it. And someone says we should have recorded it and we haven't recorded it, or we've recorded it in the wrong way. And so when you're building the beginnings of a map, you know, we've got some sort of intended purpose and we've got some sort of new data set. And the question is, you know, what sort of activities have to sit in the middle? In this case, I put data analysis, to decide whether that is a reality. So again, in terms of the key, I've started to get slightly more stylized in the way I do these maps. So I've got purposes and tasks and resources, activities and processes. And we'll see that you know, if I think about the development of machine learning, activities and processes that are definitely human, and progressively they become, you know, more machine-like in some sense. So the data's got to come from somewhere. We've got a database I've put down at the bottom, and I've stuck it in the middle because some of the data in there tends to be useful because the business is using it in some meaningful way, but it might not be A grade for what you want. And so you have to sort of get on this process of discovery, and I'll come back to sort of stages of the data science process as much as anything, because then you can think meaningfully about building a team around them. So I guess the other thing in the framework, the sort of data readiness framework, the idea is that you can't really say that a data set is A grade if it's not tied to a task in some sense, right? You need to understand the context in which the data might be used. And so we start off with not knowing whether it exists, and we end up with being able to build something, and we'll come back to what the something is off the top of it. And it can get a bit peculiar because also we tend to, for lots of machine learning or data science tasks, we have lots of different competing user needs, which are essentially built off versions of the same data. And the maturity of the data set might be applicable for one task, but not another, and vice versa, right? And so, again, when we're starting to think of what resources a company has at its disposal, or what a data manifest might look like, trying to understand what the various stages of this data set maturity might be, or how you partition them. So for example, you might have a data set that is most mature state for one particular task, but is actually only useful in sort of as a component of an underdeveloped new task as it emerges. And so databases tend to split into all sorts of data sets, various stages of utility, when you start to sort of pull an organization. So, you might have a data set might be good for one particular task, grade A, but insufficient for a different task. And so part of the job of this sort of data science team that you're thinking of building is to be able to take data sets from the earliest, most naive, underdeveloped stages of readiness all the way through to ones that are doing useful work in the company. And one of the things I guess I think about of doctrine in terms of data is annotation. So how much metadata can we add or improve to an existing data set? The other thing that I guess I've been thinking about is, or at least reading as much as thinking, is this work of Max Boisot, which Simon references in a few places, and how it's useful for thinking about data. So one of the things we can think about is the structure of an information system in an organism, right? If a company, not that the company has all of the properties of an organism, but you can think of it as having some of the properties. What's the difference between the information that we initially record versus what we do with it? And so at the first stage of the data maturity levels, this is me kind of mixing some of the things in Lawrence's data readiness levels with other people that have worked on it or thought about it. The earliest stages is literally just an existence. So it's recording of some sort of stimuli. Then as we go through this sort of cognitive capacities of a system, the first stage is some sort of perceptual filter. It's like we're going to keep some of this and ignore some of it. Second processing stage. So I've got these 3 transitions between the 4 stages of capital. Second one is some sort of conceptual filter. So we interpret the data that we've decided to keep, and we narrow it down. And some people refer to this as information. And again, I'm going to ban these words around. Sometimes they have really formal definitions, but a lot of the time they don't. And actually, to even start to understand this data to sort of information processing, which I guess would transition from Simon's divergent to convergent representations, we have to have some sort of schema. So we can't just record data in the ether. Normally we're making some sort of attribution. So sometimes that schema has to be pre-existing to meaningfully record it. Sometimes we have to develop the schema or co-develop the schema as we understand more and more about the data. And this is where things like annotation fit in, because they help you build up a richer representation as the data goes from its earliest stage to its later stages. And lastly, we've got some sort of way of situating that information in the context in which it was recorded. So not only do we have the data that's telling us about the world, but we have some sort of model about the way the world should behave, or some sort of value store of the ways we interpret stuff. And so I'm flagging this because Simon, at least online, uses the word knowledge as a separate form of capital. And here I'm using it still as the later stages of data development. And we'll come back to the philosophical implications of some of that maybe at the end. So what are we really learning? The first thing, in these 3 different stages with, or 3 transitions with 4 stages of capital, I guess the first one, and this is not exact transitions, but I think these are useful approximations. The first is like the first perceptual filter is trying to understand what randomness is, what's noise, what's measurement error, what should we record, what was recorded, what should we not record, what should we ignore. The second one is the beginnings of the modeling process, which is we start to understand what some sort of significant regularity looks like for the data that we're managing to record. And then the latter stages are thinking about how we situate those regularities. So, how do we interpret changes in regularities that we've identified? Are those changes significant? Are they not significant? So what's this got to do with building a data science team? Your first stage, your first transition is really about accessibility. So, what data sets have we got? What applications do we have in a business? How's the data currently used before we could think about new ways of using it? If I want to start with a new data set, how do I get permission, right? Can I legally process this thing? And to a certain extent, this starts to define what building a data science team might actually look like. So you've got these various different sort of activities around data governance and data analysis and data engineering, which I've put as a way of dealing with a database. And that could be one person with a skill set, or that could be multiple people, depending on the firm we're talking about. And the other thing is that as these activities or these resources mature, actually the skill set tends to mature as well, right? You can have someone that is very comfortable operating in the kind of C&D space in terms of the infrastructure and the architectures and the systems and the code bases they have to work with, and can be less comfortable at the end. So again, one person in principle can straddle multiple guises. For example, if there's enough seniority, they might deal with the data governance as well. But in practice, fairly early on, it's very difficult to get someone to do all these different skill sets. So this is where I sort of started to use the team topologies framework a little bit, not because I understand it in all its detail in terms of transitioning between types of teams, and not because the teams I run need me to understand it in that much detail, but because I think it's useful. So, data governance, as in the first instance, can I do this? Should I do this? Might be thought of as an enabling team. The actual process of ingesting data and turning it to a new purpose might be thought of as streamlined team, and the closest thing we've got to is a data science team at the earliest stages. And then more often than not, you've got to sit on top of some sort of platform team. So it's either going to be an incumbent IT department or system, or someone that sits with a data engineering hat on. Again, like some data scientists are very happy at the data engineering and some aren't. So it's when you're starting to think about building a team, it's a question of how specialist some of the roles have to be. And again, at least in my head, I haven't drawn this all out in detail for all of the maps I'm going to show you. But again, in terms of the team topologies framework, we've got 3 modes of interaction. So data governance in the first instance is some sort of facilitation, enabling your data science team to do something, and the platform team is a service, right? It's standing up infrastructure, it's maintaining infrastructure. So just to repeat myself, data analysis and data governance might be, the activities they share are around the legal basis for processing. Data governance might also play a role in InfoSec, right, in terms of everything from penetration testing, dealing with outages, etc. So let's go back and think about how to operationalize this stuff. Let's say we've got some data in a database and everyone's agreed that we're allowed to do something to it. How do we go about assessing randomness, and how do we go about assessing what significant regularity might look like? So the first thing we've got to do is we sort of go from a data discovery phase to kind of what's called EDA, or exploratory data analysis. And, the first thing to do is to decide whether the collection process was valid. We said, the person in the business says that this information, it collects this type of, or this process collects this type of data and should be useful for X. And when we start looking at it, we decide that, perhaps it's corrupted. So even at the first instance, our first data set might not progress meaningfully to the right-hand side in terms of being able to augment and mature. It might actually be that we need to start again and go back and get a slightly different data set, either from a different system, or augment it, or get a subset of data. And so again, in terms of this beginnings of trying to form a representation, here I'm sort of transitioning from C to B. Things that you want to think about, is the data legitimate? Is the origin, do you have enough of it? Is the encoding correct, right? If I managed to not record my ages as going between 120 and 200 or something, there's all these sort of basic data science things that you need to start to get to grips with. And really that starts the process of this co-evolution of some sort of schema. Now, often when you're taught data science, you're presented with this picture of the world, which is a sort of crisp DM cycle as one way of characterizing the interplay between business understanding, i.e. your user needs, versus data understanding, i.e. your schema and what it can support, separate from data preparation and modeling. So often these things are thought of as loops. And so as you progress from left to right in a Wardley map, you go up and down across these kind of tiers of components in a pipeline, and each of those transitions between components in principle might correspond to these kind of loops. And I'm going to come back to this because I think one of the useful things a Wardley map does is unroll some of these loops. And generally, as we go from left to right, we get this idea of structural deepening, which is we keep adding things to the data set, adding components in our processing pipeline so that it becomes stable, reliable, useful, just in the way that the sort of bits of the jet engine did. And the way I normally represent that when I'm talking about collections of components is with this idea of a main assembly. And so for those of you that are interested, the blog talks about the development of certain components in a jet engine, and essentially I conceptualize building data systems in the same way. So what do we do? What do we need to do to start to improve this, right? We've got, for the sake of argument, a data analyst, is being in the first stage of assessing this kind of region, D, is being recorded what's purported to be recorded, versus how do we even understand that? Often you've got to start to use visualizations. And so a business analyst and a data scientist might start to work together to be able to produce a representation of data that someone can legitimize, right? This does look like the thing we think it's. Again, the way I've drawn this, I've got some of the slides, I've got tips, whether or not anyone else finds them useful, but I tend to think of these as factor graphs. So between any two resources, depending on what the resource is, in principle, there could be some sort of activity, depending on your level of abstraction. So business understanding is linking some sort of purpose with a business analyst resource function. And a schema is being linked via exploratory data analysis to skills of a data scientist and the skills of a business analyst. And you can start, again, just with a few activities on here, you can start to think about team structure. So, if you're taking data from one format in an application database through to a purpose, you might have a stream-aligned team that goes across all of these different business units, for example. Or you might put a team together that has all of those capabilities in X number of people. When I think about drawing these things, the first thing I struggle with often is this idea of loops. So we talk about machine learning loops, but loops happen all over the place. So this idea of data being produced by a user, going into an application, being collected in a database or other, being processed, being put into the application, being given back to the user. And so invariably, when I'm doing these sorts of maps, I actually separate the inflows and outflows of data, so source and sink. So in my head, most of the time, I linearize these flows so that information is coming, or data is coming into a processing pipeline at the bottom and is coming out at the top in some sort of purposed or user need. And of course, as soon as you start drawing them, I almost invariably ignore the duplication nodes at the bottom. So I ignore the fact that I've got user data coming actually from a user that's at the top and back and forwards. I just find it easier to stick to basically the flow of information or flow of data in one direction. Second thing, that's a sort of high level observation, is that most of the time when we're talking about the maturity of components in a Wardley map, we're thinking left to right. And in the sort of pure development process, that may well be true, but often the transition from left to right in the data, type of capital, as it were, I think is actually sort of offset with some sort of lifting or moving towards the top of a Wardley map. So often when we have a process, and it's working well, not only is it making the data more mature, but it's changing what can be done with it, and therefore it's changing its position in the structure of a value chain. So again, in my head, I sort of think of these systems as going bottom left to top right. And so if we think about a task or an anatomy of the task, we take some input, which is data that we store. We do something to it. Here I've put engine, but it could equally be activity, to make a prediction, to enable us to make a decision, to take an action, to have an outcome. And the data might flow back from the outcome to the input, and we might do might do other things to it. But as a first stage of thinking about the structure of a task within a business, this is the sort of thing I think about. And when I'm designing, or when I'm using a map, I tend to think about what's the incumbent activity, i.e. I've got this task in black in the middle, and what's the improved task I might want to get to. And I put this on the right hand side in red as a reminder, as a mnemonic as much as anything. In reality, almost all of your design decisions end up starting somewhere over here and ending up all the way over here. But I often hang the desired state off to the right hand side. And you'll notice also that I've actually got rid of the stages of capital altogether, right? Any one of these maps might actually be zoomed in on the sort of full 4 stages of evolution as framed by Simon. But we're in it. I just take it as a sort of the selected level of abstraction is not one on the quantization of the forms of capital, but is still quantized on forms of capital at whichever point in it might exist. So if we go back to building a data science team, should we do X? What do we need to do to decide whether we should do something? First thing we need to do is fill in a DPIA, at least in principle we do. And the DPIA is quite a good component on a data science map, because it's an evolving document. As things become clearer, you should create it at the outset, and as things become clearer, it should alter and change. And here I've linked this to one of many systems that you could use to structure your DPIA. It's called OneTrust. But again, depending on the size of the organization, the analyst might then need a whole load of other people to help craft or make that decision. And indeed, for any significantly complicated organization, the different bits of the DPIA should get filled in by essentially different specialisms. Now I've built out this map a little bit further. So we've decided we want to do something, and we've decided that we've got some data science capability, and we start a discovery phase. And in the discovery phase, the sort of first version of a DPIA and the data set are sort of in line, as it were. The thing to note here is that, what is the thing to note here? Completely forgotten. I'll come back to it. Well, I guess the first thing actually down here. So, one, the data exists, and two, we've decided to begin our journey that the origination is legitimate. And then we might want to iterate this data set, and it might be that the first thing we need to do is decide if we've got enough data. So, we've gone from data set 0 to data set by deciding that it's coded correctly and we've got enough of it. And very frequently, the first answer to this, can the data support X, is no. So you then start reframing the business understanding. You change subtly the purpose that can be exploited. And so this is, as we go around and we think about this CRISPR cycle, here a discovery made at what a data set can or cannot support manifests itself in the evolution of the user needs that might be satisfied. And again, if we think about, again, this could be a single structure in a team, but invariably, this is starting to look a bit more realistic. So we might have some sort of platform team at the bottom. We might well have two different types of stream-aligned teams, one identifying user needs and one deciding whether they can be satisfied in any meaningful way with the data available. And then you might end up with a different governance structure. So here I've got the purple sort of supporting team with a chief data officer, but they might actually have a kind of data governance board. It might have the head of security. The head of security might feed into the DPIA with a whole load of restrictions on what you can and can't do, whether it's personal data, etc., etc. And so this is, this step before we've done any modeling has got a team, at least in principle, of a reasonable size, and all we've done is one loop through business understanding, data understanding cycle. I guess the first thing when I think about here are the assets or resources on a kind of data science Wardley map, is that sometimes it makes sense for an individual asset to just mature and you've got a single version of it, like the DPIA. The DPIA 0 to DPIA 1 should continue to evolve in some sense. Whereas often with data assets, you want to be able to keep versions. So versioning, I want to know what my original data 0 data set looked like, because if in production something else goes wrong, I can start to go back through my data sets and figure out where the error might have been introduced. So now I'm going to focus on this central section and look at sort of machine learning patterns in more detail. Again, so abstraction at the level of the map, deciding what the thing you're focusing on when you're focusing on it. So machine learning, we've talked about data collection and a little bit about data verification. Almost all of the literature and the sort of interesting stuff it happens on this modeling box in principle, but the modeling is actually a tiny component of an overall system. What goes on in the modeling? We clean data, we transform data, we try and build a model, we see whether the model works, we try and alter the model slightly, we go back. So it's an empirical, iterative process. Sometimes we get a model that we think is working, we try it out and we go backwards and forwards. And so all of these things essentially are looped together. And when I think about trying to understand the machine learning process or operationalize it, in my head, I just see a Wardley map really. So I see a pipeline that takes in data at the bottom and spits out processed data at the top, because we've sort of linearized our flows. And then I see, newer versions of a system and older versions of the system as the pipelines go left to right. Oh, where's my cursor gone? So, and I think some of you will have seen this before, but this idea of, I don't disagree at all with Simon's characterization of visible and invisible and industrialized or not industrialized. But again, when you're starting to do this, I think a lot of the time it's just quite easy just to think about the time normalized in slightly different ways. And so this little animation, which I hope will show up on the video, or at least hope will run, shows the sort of intuition behind what happens on a Wardley map. You've kind of gotten time normalized in two different directions, and things start at the top and sort of flow across and antiquate and go down. And so your data assets, to a certain extent, do the same thing. So let's have a look at that. What does that look like in terms of a Wardley map for this whole process? Well, not this whole process, but part of this process. I think of it like a lattice. So I think of data sets going from left to right. I think about schema going from left to right. I think about models going from left to right. I think about engines, and we'll talk about engines in a second, going from left to right. And in my head, I have this kind of backbone of the system I'm trying to build, and I have a set of different people across it. And so rather than thinking about loops, I think about how they sort of iterate together, both as teams of people, but also constellations of components or constellations of assets. And so here, I'm not saying this is necessarily the only way to do this or even correct. There's a few design decisions, but I've broken out the CRISPR process in terms of activities, broadly going bottom left to top right and in up to the modeling phase. And then a series of, or at least one taxonomy for how to break apart these resources or assets. So if you think about patterns, machine learning patterns, what do we really see? How do we see this play out on a Wardley map? Okay, we see iteration or loops be some sort of zigzag between adjacent components in a data supply chain or data value chain. We see, I tend to think of things as seeing waves or fronts going bottom left to top, where you get chains of components and activities that need to sort of co-occur. And when we're working on a data set for the first time, we're doing discovery, but when we're working on the second version of the data set, we're doing data understanding, and so on and so forth. And you also start to see slight discontinuities about when these things can be brought in. So you can have a model, you can model at a really early stage that just helps you do. So it's not, you're using a model not to produce an end model for the process we're trying to create, but you're using a model as a way of exploring how the data behaves and what might be the best approach. Another thing you get is I guess you can start to think about the cadence of the different systems in the data value chain. So, you might have to go through several different iterations of a model, and the schema or the metadata associated with the value of the data set hasn't changed at all. And you might get the data set moving more slowly through its maturity cycle than a particular engine or model. And then this is one of the things that I still don't understand when it comes to cartography. I don't quite understand a way to split systems sensibly, right? So you could have the modeling process go through the early stages of capital and then get deployed and become, in my head, I think about a model during development and an engine during deployment, because the engine can do useful work. It's got to a stage. And so I often think about engines basically starting afresh. As soon as the model's got to start working, I think of the engine starting afresh and it having its own maturity cycle. And again, so it means that you end up with lots of discontinuities. I think one of the other problems with this mapping at the moment is often in different forms of capital on a map, you'll get massive separation. And you can always think about it at a system level by aggregating and taking a mean position of the components in the main assembly. But when you see all of the things on a single map, it becomes confusing. And then secondly, I talked a little bit about the frequency or the number of resources at different stages of development, but some of them will move, some of them will be fairly infrequent, right? You might not have that many versions of a DPIA or a judgment process compared to the number of systems underneath it. So some of the cadence differs considerably, and the cadence differs considerably and can influence the way you structure the teams working as well. So I've done this map here is kind of, or this learning lattice, as I'm referring to at the moment, is one way of representing the change in structure of information within the business. It's not a Wardley map or doesn't have all the details of the architecture that would support it. So some of the roles, but I haven't put in a whole load of systems that underpin it. What sort of systems underpin a general machine learning pipeline? I haven't built you this Wardley, I haven't drawn a picture of this Wardley map, but here's a sort of generic pipeline. Data lake would be some sort of database at the bottom. We've got a whole load of kind of moving data around. I haven't talked at all about structure of data, of validation and testing data sets, largely because for the most part, I don't think you need to do it on a map, but you can draw the structure of these sets on a map. And when you've got multiple models feeding off different variants of data sets, it becomes useful. And I put this slide in just the tooling and the standardization of the tool chain in data science and machine learning is changing rapidly and is a little bit overwhelming. And I've only used a handful of these components. And in reality, lots of companies aren't even using these components that you can point to. As if we think about Simon's, build, buy, outsource, a remarkable number of companies at the moment are keeping the machine learning tooling in-house. So I guess they've used things like MLflow and Airflow, but for a large set of companies, how they do a model registry and keep track of all of the different versions of a particular model or variety of different models that might be applied for different applications, or how they do workflow orchestration. So for example, how do they make a transition between a model and an engine and a series of data sets? There's not a lot of open standards ways to do this. What is changing is the industrialization of ML. I think we, in terms of the way Simon thinks of industrialization, I think we're at very early stages of structuring ML. And one of the patterns that I think is interesting is this ILC pattern as it plays out with very large models. So in the last 2-3 years, we've started producing sort of web scale models. And it's an interesting sort of macroeconomic point about the relationship between consumer and producer. So China has started building massive models that are intended to be used at a sector level. So all companies have API access essentially to a large model that will allow them to operate in a particular market. I started the talk by thinking about the structural deepening of data. And I guess what I mean here is, as we go through the process of generating a purposed system that is dependent on data for satisfying some sort of user need, we tend to go through a series of activities that essentially create assets that then have to attach themselves to the data, that then have to be there during deployment. So the cleaning process of deciding what is good data and what is bad data, what's been recorded correctly, for example, as we move through this process of creating a system, it has to at some point turn into a data unit test on a deployed engine that says, if the data coming in doesn't look like this, then throw a flag or a warning, or don't give an output. And so as we collect, as we build systems that get to the point of utility where they can work, they invariably become more and more complicated. And I guess a few throwaway comments here, because I think that they can be pulled apart. But I like the fact that Simon does some of these grand visions for what you can compress into a 2D space. As we go left to right, the data scientist in me thinks that it's quite easy to move from sort of a frequentist version of probability through to a Bayesian version of probability, where you get tied into assumptions about how the world works that you don't necessarily. And I guess a very general overview is, actually, when I draw the maps, is that on the left-hand side, stocks, it's very easy to think about things as separate systems, so thinking in stocks is strong. But by the time you end up on the right-hand side, thinking in flows is better. And so you get this ossifying of information flows in a business. I think there's probably quite a lot of work to be done here. Again, this is just my first attempt at trying to put some of this together, but as you go from, I think there's some physics to be done here, and perhaps someone on the call knows this better than me, but at these different stages of data maturity, you go from perhaps a thermodynamic idea of entropy on the very left-hand side of this diagram through a kind of Shannon entropy somewhere in the middle. And actually everything written about information theory is a very narrow band, in my understanding of what you can display on a map. And then I can't really see that anyone has got to grips with entropy over on the right-hand side of the system at all. Although I'd like to know if someone has read something that is relevant there. So I said I'd talk about building teams. I've tried to give you some sort of machinery to help you think about building teams. Here's the latest team I've built to give you some idea. I've got several complicated subsystems, which are basically different types of machine learning teams. This is the team that I guess I've built over the last 3 years, as was in Q1. So you can see there's a few structural things to sort out in terms of reporting lines, but to give you an idea of functional components, there is a sort of core IT team that deals with the data infrastructure, the serving of data. There are 3 kind of business aligned streamed teams working on various sorts of user needs at various stages of their maturity. And then there are 2 enabling teams. I've got an enabling team, which is basically data science practice, so that the data science tooling and methodology is shared across the team properly. And I've got one on software engineering to help with deployment and scaling of these systems, etc. Future work. I guess the thing that interests me, and I started to do some mapping in this area, is human machine systems. So I didn't really talk about it. I put here a pipeline around the role that judgment plays in using a prediction in a decision. And there are lots of variants of how a human versus a machine can be put into this data supply chain. And so at some point I will get around to, I guess, doing some maps in that space. I've been doing quite a lot of reading on the foundations of 2-dimensional representations. So I think the beauty of a Wardley map is that it's a way of framing a complicated stroke complex, I don't want to get into that system, in 2D. And it turns out that there's lots of work being done on how to produce authentic, useful, low-dimensional representations, but it's basically still a research area. Turns out there's lots of problems. This one is from a couple of months. I have partway got through translating the original Wardley book into Chinese. I know I see John Grant is on the call. I told him I would do it. So I guess some of my students have been doing that, but I will have the first 6 chapters by the end of the month, and then I'll get around to doing the rest of it. Follow up, I guess this is my ask with 1 minute left. My ask is that we spend some more time worrying about the practice of cartography. So I've put a list of common problems, everything from co-location of nodes to edges clashing to thinking about the best way to unravel loops. I guess my reading to date on the side of math side of things is that there's no absolute right way to do this. So as a community, coming up with some useful standard ways of doing something, I think is a useful step forward. And perhaps Simon's Academy or whatever it was called can do that. This is my favorite, most recent map, topologist map, which I've left up there. I've put some papers in as further reading. And given what I've said so far, I haven't actually talked about strategy. One of the most annoying things I find about these presentations, to a certain extent, is we don't get into the, because you have to know enough about a particular system, we never get into the details. But this is a real map of a data supply chain in a sector that I work in. Every node on this is a company, basically. And this is an example of starting to do, without looking at all of the details, it's an example of doing strategy at a kind of sector level. 2 minutes before coming on, I discovered MapKeeper. So I've made my first map. And if someone wants to talk more about data strategy, this is me starting to sketch out what I think of data strategy going forward. But given that we've got the time available, I will stop and take questions on the stuff I did talk about rather than the stuff that I didn't.
Any other questions? Perhaps we have time for one more.
Data mesh. Yeah, I have seen data mesh. I don't know data scouts. So I think that what I'm talking about here is sort of a level above a data mesh slightly. My reading of data mesh is a lot to do with architecture of moving things around. And I guess I think a lot about, the semantics of the problems being tackled as much as anything.
Mm-hmm. Okay, we are almost on time. Thank you, Alastair, for the presentation. Thank you, everyone, for participating. And hopefully see you soon. Bye-bye.